Welcome back, everyone, to another deep dive. We're going to be taking a look at some fascinating research on AI today. Specifically, how scientists are trying to teach AI to understand us better.
Right.
And it all comes down to this concept of multimodal large language models, or MLLMs for short.
MLMs, yeah.
I think AI that can process not just text, but images too.
Yeah, so what's really interesting here is that, these open source MLLMs, they're already doing a great job with tasks like, identifying objects in an image,
Right.
doing OCR and things like that.
Yeah.
But then they kind of hit a wall when you start asking them these more complex, open-ended questions.
Yeah.
The kind that require real understanding and reasoning.
So like the difference between asking for a recipe based on a photo
Exactly.
versus like asking your AI for travel advice based on like a scenic picture.
Yeah. One is, way more challenging because it needs like more context.
Way more context, exactly.
Exactly. Yeah. And that's really the core problem that this paper that we're looking at is exploring.
Okay.
It's called OmniAlign-V, towards enhanced alignment of MLLMs with human preference.
Catchy title.
Yeah. And the basic idea is that, these open source models, they're lagging behind models like GPT-4.
Right.
When it comes to, giving these really nuanced human-like responses.
Okay, so they're good at the basic stuff, but not so much the deeper thinking.
Not quite there yet. Yeah.
Yeah.
And they actually use a great example in the paper to illustrate this.
Oh, okay.
Comparing responses about the loading and unloading process at a busy port.
Okay. Busy port. Lots going on.
Yeah, lots of moving parts. So GPT-4o, was able to understand kind of the whole picture, the physical process, the impact on trade, even potential logistical headaches.
Wow.
Whereas, the open source model they were looking at, Intern VL276B, just gave a very basic description.
So like surface level.
Very surface level. Yeah, it's like it was just seeing the image, but not really getting what was going on in a broader sense.
Interesting. Okay, so why should we care about this?
Yeah.
It's not just about, AI sounding smarter, right?
It's not just about sounding smarter. It's really about, the future of how we interact with AI.
Okay.
Like imagine a world where your AI assistant, really gets your needs and gives you insightful answers.
Yeah.
And even helps you to be more creative.
That would be pretty cool.
That's what this research is ultimately aiming for.
That's the goal.
Yeah.
Okay, so that's the problem they've identified.
Right.
What's the solution that these researchers came up with?
So they created this thing called OmniAlign-V.
OmniAlign-V.
Yeah, it's basically this huge data set of image question answer pairs.
Okay.
And the idea is that, this is designed to fix this alignment problem.
So they're using AI to train AI.
Kind of. Yeah. It's pretty meta.
It is pretty meta.
When you think about it, but
how do they even do that? Because, we hear all the time about how these big commercial AI models have access to these massive data sets, and that's how they get so smart.
Right.
So if these open source models don't have access to that, how do they stand a chance?
So that's where the clever part comes in. So they actually use GPT-4o.
Oh, wow.
Which is already known for being, super smart to create the questions and answers for this data set.
Oh, that's smart.
Yeah. So they're kind of leveraging this existing technology.
I see.
To really boost the capabilities of these open source models.
I like it. Okay, so how does this OmniAlign-V data set, like how does it actually help MLLMs understand things on a deeper level?
So it's not just about simple question and answer pairings.
Okay.
They've made this data set incredibly diverse.
Okay.
So we're talking knowledge-based questions, inferential reasoning, creative tasks, even tasks built around understanding infographics like charts and diagrams.
So it's throwing all these different challenges at it and kind of forcing it to think in different ways?
Exactly. Yeah, it's like, for a picture of the Colosseum, for example.
Yeah.
The AI might have to not only explain its history, but then also come up with an itinerary for someone visiting it.
Oh, cool.
Or picture a hockey player getting ready for a game.
Yeah.
The AI might have to try and describe the player's thoughts and emotions.
Okay.
There's even an example where they use an infographic about small businesses. And the AI has to figure out, the strategies that those businesses use to compete with larger companies.
Wow. So we're talking about AI that can interpret emotions, understand strategy, even plan trips.
Yeah.
That's pretty impressive.
It's a far cry from just, recognizing objects in an image.
Yeah.
If this kind of training works, the potential for human-like interactions with AI is huge.
It's huge, yeah. Absolutely. And this is where this whole idea of semantic richness comes in.
Yep.
So they didn't just use any random pictures for this data set.
No, they were very deliberate.
They were picky.
They were picky. Yeah, they chose images that, had layers of meaning for the MLLMs to learn from.
Makes sense. You can't teach AI to understand deeper meaning if you're not giving it anything meaningful to work with.
Exactly.
So what kind of images didn't make the cut?
So they give the example of a picture with a bunch of tents.
Tents.
Yeah. Yeah, sure, it's visually complex.
Yeah.
But there's not a lot of depth there.
Right.
For the AI to really sink its teeth into.
Okay, so tents visually interesting, but not exactly thought-provoking.
Precisely.
Yeah.
It's not enough for the image to just be busy.
Yeah.
It needs to have that extra something to help the AI learn to understand the world the way we do.
So they built this incredible data set.
Yeah.
But how did they actually test if it worked?
Right. So they compared the performance of MLLMs trained on OmniAlign-V against those trained on other data sets.
Okay.
Using a variety of benchmarks. And the results were pretty impressive.
Okay.
The models trained on OmniAlign-V showed, a significant improvement in their ability to provide answers that align with human preferences.
So training AI with this focus on human preferences actually works.
It seems to, yeah.
But wouldn't a project like this require an insane amount of resources?
It certainly does. And the researchers themselves, acknowledge that the current scale of the data set, while impressive, might not be enough for truly large-scale training.
So bigger is still better.
It seems that way. Yeah, and they specifically mention, cost limitations as a major obstacle.
That makes sense, even with, clever tricks like using GPT-4o to generate data.
Right.
Bigger data sets are still going to be more expensive to create.
Exactly. Yeah, and it highlights, one of the key challenges in this field.
Yeah.
Finding ways to create these rich and nuanced data sets without breaking the bank.
Right.
But even with those limitations, the results they've achieved so far are really promising.
Promising. Yeah, it sounds like OmniAlign-V is a big step in the right direction for teaching AI to understand us better.
Absolutely.
But hold on, they didn't just create this data set and call it a day, did they?
No, not at all. They went a step further
and
created a brand new benchmark.
Oh, wow.
Called MM-AlignBench.
MM-AlignBench.
Yeah.
Okay.
And this is specifically for evaluating, how well MLLMs understand and respond to complex questions in a way that matches human preferences.
So they raised the bar for AI.
They did. And it's because, the existing benchmarks weren't really cutting it.
Okay.
They were either too simplistic or just not focused enough on human preferences.
I see.
So MM-AlignBench aims to provide a much more robust and nuanced way to measure, how human-like these AI models are becoming.
Okay, that's fascinating. But before we dive into the nitty-gritty of MM-AlignBench, let's pause here and give our listener a moment to digest all this incredible information.
Sounds good.
We'll be right back after a quick break. All right, so we talked about the problem and we talked about the solution.
Now let's get into the details of how this OmniAlign-V dataset actually works its magic.
So they use a few different methods to fine-tune the MLLMs with this data.
Okay.
One is called Supervised Fine-Tuning, or SFT for short.
SFT.
And you can think of it like, taking an already talented athlete and giving them some specialized coaching to really refine their skills.
So they're not starting from scratch. They're taking an existing model and making it even better.
Exactly. Yeah. So they took two existing MLLMs, one based on InternLM 2.57b and another on Quen 2.532b.
Okay.
And they fine-tuned them using OmniAlign-V.
So they gave them a crash course in human thinking.
That's a good way to put it. Yeah.
And I'm guessing the results of this crash course were pretty impressive.
They were. Yeah, the fine-tuned models showed, a remarkable jump in their ability to answer questions in a way that humans preferred.
Across the board?
Yeah, and it wasn't just on one specific test, it was across the board.
Oh, wow.
Including MM-AlignBench Wild Vision and MIA-Bench. Okay, so we can confidently say that OmniAlign-V is a game changer for training AI to understand us better.
It's looking that way.
But, hey, you mentioned something called direct preference optimization earlier.
You have a good memory, yes.
DPO.
DPO, that's right.
That sounds pretty important, too.
It is, yeah. So DPO, or direct preference optimization, is another powerful way to align AI with human preferences.
Okay.
And it turns out that OmniAlign-V is incredibly valuable for that as well.
So they used the same data set for both SFT and DPO?
Well, not exactly the same.
Okay.
For DPO, they created a slightly modified version of the dataset called OmniAlign-V DPO.
OmniAlign-V DPO.
Yeah, they used a technique called reject sampling.
Okay.
To essentially show the AI what not to do.
Interesting.
So imagine a coach, pointing out an athlete's mistakes.
Yeah.
So they can learn and improve.
So by showing the AI bad examples, they helped it understand what good responses look like.
Exactly. Yeah, it's kind of like a reverse psychology approach.
That's clever.
And the results were pretty remarkable. After going through both SFT and DPO, their model actually outperformed Quen2VL72B, which is considered, a leading model in the field.
Wow.
That's been trained on an enormous amount of data.
So it's like a David and Goliath story in the AI world.
Kind of, yeah.
It shows that quality data focused on human preferences can sometimes beat out sheer quantity.
Absolutely, yeah. And this is really important in the context of open source models.
Right.
Because, they often don't have access to the same vast data sets as their commercial counterparts.
Right.
But they can still achieve amazing results with the right kind of targeted training.
This is really encouraging news for the future of AI development.
I think so.
Now let's get back to MM-AlignBench, that new benchmark you mentioned.
Right.
Why did they go through the trouble of creating a whole new benchmark?
Because, as we said, the existing benchmarks, they just weren't cutting it.
Okay.
They were either too simplistic or not focused enough on human preferences.
So what makes MM-AlignBench so special?
So for starters, they handpicked a really diverse set of high-quality images.
Okay.
From places like SAM1B, CC3M test, AI2D chart QA, and infographic VQA.
They pulled from everywhere.
Yeah, they really went all out to make sure that the images were, complex and full of meaning.
Okay, so the pictures themselves are designed to really test the AI's ability to understand things on a deeper level.
Exactly.
What about the questions?
Right, so for each image,
Yeah.
they had experts carefully craft open-ended questions
Okay.
that required the AI to, understand human preferences.
Okay.
It wasn't just about identifying objects.
Right.
It was about understanding nuance, context, and even emotions.
So they set a high bar for these AI models.
They did.
But who actually grades their performance?
So get this, they used GPT-4o as the judge.
No way.
Yes.
So they're using one of the smartest AIs out there to assess the intelligence of other AIs.
Exactly. It's like the AI equivalent of an Olympic judging panel.
I love it.
Yeah, and this incredibly rigorous evaluation process is what makes MM-AlignBench such a valuable tool.
Okay.
For, pushing the boundaries of AI development.
Yeah.
And making sure that these models are aligned with our values and preferences.
All right, so MLLMbench sounds like the ultimate AI test.
It's pretty tough.
How did the different MLLMs stack up against each other?
So the closed source models like GPT-4, Claude, and Gemini.
Her ones with the massive data sets.
Right, those are the massive data sets. They performed very well.
Okay.
They consistently gave answers that aligned with human preferences.
Not too surprising given their access to all that data.
Right.
But what about the open source models?
So this is where it gets interesting.
Okay.
While models like Quen2VL and InternVL2 were great at things like object recognition and OCR, they struggled more with these open-ended, nuanced questions.
So they're good at the basics, but not yet masters of human-like thinking.
Yeah, there's still a gap to close.
There's a gap there.
Yeah, and that's where projects like OmniAlign-V and benchmarks like MM-AlignBench are so crucial. They help developers focus on aligning their models with human preferences.
Yeah.
Which is key to creating AI that is truly beneficial and reflects the best of what humanity has to offer.
Okay, speaking of OmniAlign-V, how did the models trained on this data set perform on MM-AlignBench?
So remember that Elevate OA32B model we discussed?
The one that was fine-tuned with OmniAlign-V?
Yes.
And actually outperformed Quen2VL72B, even though it was trained on a much smaller data set?
That's the one.
That was a pretty big surprise.
It was a big surprise.
Yeah. So how did it do?
So on MM-AlignBench, it continued to impress.
Okay.
It performed exceptionally well, even beating out some other strong MLLMs.
So this really drives home the point that training AI with a focus on human alignment can lead to some truly remarkable results.
Absolutely.
It's not just about the size of the data set, it's about the quality and how it's used.
Right. And when they took this model
Yeah.
and further enhanced it with DPO,
Yeah.
using that special OmniAlign-V DPO dataset,
Right.
it became even more powerful. It achieved a winning rate of 72.6%.
Wow.
And an average reward of plus 33.5 on MM-AlignBench.
So it actually surpassed Quen2VL72B.
It did.
That's incredible. And this is all thanks to a data set that's laser focused on aligning AI with human preferences.
It's pretty convincing evidence that they're onto something here.
It is. Yeah. Okay. So
Now, to really understand the impact of each component of OmniAlign-V. They conducted a series of tests called ablation studies.
Ablation studies?
Yeah.
That sounds a bit intimidating.
It's not as scary as it sounds. Just think of it like taking apart a complex machine to figure out what each part does.
Okay, I can see that.
So they tested their model's performance using different chunks of the OmniAlign-V data set to see which parts had the biggest impact.
So they were essentially trying to isolate the secret sauce of this data set.
Exactly. Yeah, and they learned a lot.
Okay, like what?
For example, they found that the performance gradually improved as they added more and more diverse tasks from OmniAlign-V into the training process.
So variety is key when it comes to training AI.
Variety is key.
Makes sense to me.
It does, yeah. But here's something particularly interesting.
Okay.
They discovered that the instruction following data played a crucial role in boosting performance across all the benchmarks.
So teaching the AI to follow instructions is really important.
It seems to be. Yeah, we humans do love to give instructions.
Oh, that's kind of our thing.
It is. And they found another interesting tidbit.
Oh.
The data related to creative tasks.
Okay.
Like, writing stories or brainstorming marketing campaigns.
Yeah.
That mainly helped on MM-AlignBench.
Okay.
But not as much on the other benchmarks.
Why would that be?
So that's a great question.
Yeah.
And they think it's because those other benchmarks like Wild Vision and MM-Vet, they don't actually include those multimodal creative question types. In other words, they're not designed to test the AI's ability to be creative.
I see.
So training on creative tasks doesn't really help them in those specific tests.
So it's like studying for the wrong exam.
Exactly, yeah.
It highlights how important it is for these benchmarks to be comprehensive.
Right.
And to keep pace with the evolving capabilities of AI.
Absolutely.
We need to be testing the full range of skills if we want to understand where AI excels and where it needs more work.
I completely agree.
So now, before we get too carried away with the success of OmniAlign-V, it's important to remember that every research project has limitations.
Of course.
What would you say is the biggest limitation of this particular project?
Well, based on what we've discussed, I'd say the cost of creating even larger data sets is a major roadblock.
Yeah, the researchers themselves admit that the current scale of the data set, while impressive, might not be enough for truly large-scale training.
Right.
And they highlight that cost is a major limiting factor.
At a big hurdle.
So even though they found a way to make the most of their resources bigger, is still better when it comes to AI training?
For now, it seems that way.
Yeah.
Yeah. But they also acknowledge that there's still a lot more to learn about the nuances of aligning AI with human preferences. This research is just the tip of the iceberg.
Right.
There's a whole world of possibilities still to be explored.
It's a good reminder that we're still in the early stages of AI development, and there's so much more to discover and understand.
Absolutely.
So as we wrap up this deep dive into OmniAlign-V and the world of multimodal large language models, what's the one key takeaway you want our listener to walk away with? For me, it's that we're not just making AI smarter in like a general sense. We're talking about making it smarter in a way that aligns with like our values,
right?
Our preferences, our way of seeing the world.
Exactly. And that's what makes this research so exciting. We're moving beyond this idea of AI as just a tool, and we're starting to think about it more as a partner. A partner that can understand our needs and help us solve these complex problems.
Yeah. And maybe even inspire us to think in new ways.
Yeah, like having a super intelligent teammate.
Right.
Who's always there to bounce ideas off of.
I like that. And as AI continues to evolve, I think it's crucial that we keep this idea of partnership in mind.
Absolutely.
We need to make sure that AI is used ethically, responsibly, and in a way that benefits all of humanity.
Yeah, it's not just about the technology itself. Right? It's about how we use it.
Exactly. And on that note, I always like to leave our listeners with a final thought.
Okay.
To chew on a little something to spark their curiosity and keep the conversation going.
I love it.
Yeah.
What do you have for them today?
So we've seen that, AI can be trained to understand and respond to complex questions in a way that aligns with our preferences.
Right.
But what happens when AI becomes so good at this that it can anticipate our needs before we even articulate them?
That's a fascinating question. What? Will we reach a point where AI becomes so integrated into our lives that it feels like an extension of our own minds?
It's mind-boggling to think about.
It is.
Will it blur the lines between human and artificial intelligence?
Yeah.
Will it change how we define creativity, problem solving, even consciousness?
Those are big questions.
They are big questions.
And I don't think anyone has all the answers yet.
Right.
But that's what makes this field so exciting.
It does.
We're on the cusp of a technological revolution.
Yeah.
And it's up to all of us to ensure that AI is used to create a brighter future for everyone.
Well said. I think that's the perfect note to end on.
Yeah.
A huge thank you to our expert for sharing their insights with us today.
It was my pleasure.
And to our listeners, be sure to check out the show notes for a link to the full research paper on OmniAlign-V.
Yes.
Along with some visual examples from the dataset. It's well worth a look.
Definitely.
Until next time, keep exploring, keep learning, and keep diving deep.